In this video, we'll have a closer look at the Lewis theory of acids and bases. All Bronsted-Lowry acids are Lewis acids. This is because of the ability of the H+ ion to accept a pair of electrons. But not all Lewis acids are Bronsted-Lowry acids. In the following reaction, a complex ion is formed, but there is no transfer of a proton. So in this reaction here, the CrCl3 is acting as a Lewis acid, and the ammonia is acting as a Lewis base. Ammonia has a lone pair of electrons, and the CrCl3 has the ability to accept a pair of electrons. On the right, we have these square brackets which indicate that this is a complex ion. So this reaction can only be described using Lewis acid and base theory because there is no proton transfer. Next, we look at Bronsted-Lowry acids and bases. In this reaction here, we have ethanoic acid reacting with water to form the ethanoate ion and the hydronium ion, which is the H3O+. So in this reaction, the ethanoic acid donates a proton to the water. This proton here goes to the H2O, and that gives us CH3COO negative, the ethanoate ion, and again the hydronium ion, which has gained that proton to form H3O+. So the ethanoic acid is acting as a Bronsted-Lowry acid, and the H2O is acting as a Bronsted-Lowry base. Now in the backward reaction, because this is a two-way reaction, it'll form an equilibrium. In the backward reaction, the H3O+ is acting as a Bronsted-Lowry acid, and the CH3COO negative is acting as a Bronsted-Lowry base. This H3O+ hydronium ion is donating a proton to the ethanoate ion, and that's forming ethanoic acid and water. So let's have a summary. Lewis acids must be able to accept a pair of electrons. Lewis bases must have a lone pair of electrons to donate. And a dative covalent bond is formed in the reaction. Here's the example we looked at previously. We have NH3, which has a lone pair of electrons. That's acting as a Lewis base. And we have BF3 with its incomplete octet that can accept a pair of electrons, so that's the Lewis acid. And this arrow represents the dative covalent bond. And next, Bronsted-Lowry theory. Bronsted-Lowry acids donate a proton, and Bronsted-Lowry bases accept a proton. And here's the example we looked at earlier. So let's have a comparison of the two theories. So the Bronsted-Lowry theory, the acid is a proton donor and the base a proton acceptor. And in the Lewis theory, an acid is an electron pair acceptor and the base an electron pair donor.